It's an intriguing name, a simple but intriguing name. So I'm just going to keep you guys on your toes and let Ben Bassat start his session and present his speakers.
Yeah, I'm sorry. Okay, my name is Ami, and the subject, as you already see in the board, is the makers movement or the makers culture. This is a very broad term, and today we will touch only on top of it, on tip of it. We have 3 members, or I think we have some surprise. Will you join us? And your name, please? Shai Goitai. Please have a seat. I don't have any idea what are you doing, but you will introduce yourself. Anyway, so each one of the members here of the panel will introduce himself later and produce its making. But before that, please, all of you honored members of the panel, please have a look on the board. We have a sort of, I would call it philosophical note. And I would like each one of you, please relate in short, in 1 or 2 or 3 sentences to this note. I will read it to your benefit. AI, clever machines and robotics are all around already. Is the makers movement our last attempt as human beings to regain control? So this is a sort of question. Who would you like to start? First? Nimrod, okay.
I guess. Well, it's a pretty broad question. I guess the premise is that, as I understand it, is that as technology advances, we see less of the low-tech making. I guess that's maybe what you mean by regain control. I mean, we see more and more people using technology and not as many makers, not as many artists, not as many people using low-tech to build things, to build things with their own hands. I actually see that a little bit differently. I think that technologies today are amazing in terms of the fact that they support makers and allow people access to technology and allow people to make things in ways that were not previously available. For example, technologies such as 3D printing today allow people access to technologies that only 10 years ago were not even available for the high-tech industry, to the aerospace industries and so on. We have people today in high school who have access to machining tools and rapid prototyping, and that is actually enabling, in my opinion, people to be more productive as makers and to use these new high-tech tools and these new technologies in order to actually take this art or this passion of them forward and use that in better and more productive ways. So I actually see that as a positive.
Okay, thank you. Makers of the 21st century. Liat, would you like to comment? Just volunteer.
It's very vain and arrogant, maybe, because makers were here through the entire human period, so everybody were making things, and today we call it makers, but it's just the same, different tools. And even saying that we will build things that will overcome our ingenuity is something that is vain, because we're not that smart, I think.
I don't really understand the question, but in other words, I still don't know what to think about the makers movement. I don't know if I'm a part of the movement. What I do is basically art, and to me, creating or making stuff as a 21st century artist is really utilizing, my palette is not oil and brushes anymore. It's software, code, and making, the tools that enable me to execute my art and push the art language forward. So probably making is sort of this fusion of being capable technically, but also doing meaningful art. So I think there is a movement. I don't know if I'm a part of the movement, but as Liat said, people have the urgency to create and be creative, and you just see this iteration in 21st century now.
Yeah, I see. Shai, would you like to say something?
Hello? Yeah, I think. Yeah, well, I myself am not an artist, more inventor, entrepreneur, designer. The way I see it, we're physical beings and we're flooded with technology. It's only a natural step to regain control and using real physical things. I think everybody is a maker, by the way. We all make stuff. And the guys that are considered makers, they have some know-how, how to make it happen and how to show off their stuff. But I think that'll always stay there.
Okay, I don't think we got a complete answer for that, but I don't think we can give it right now complete answer. So I suggest we will start with the panel, and the first member will be Nimrod. Nimrod, please, first of all, introduce yourself in 2 sentences, and then go ahead.
Well, 2 sentences. Okay. I'm Nimrod. I'm a mechanical engineer, and you can stay on stage. That's fine. I'm a mechanical engineer, and I'm co-founder of a company that helps entrepreneurs develop their patents and bring them from ideas to real products, from concept to basically mass production. And I'm going to talk about something completely different today. I'm going to discuss a group called Space Eyal, which is an Israeli team that tries to send basically a spaceship to the moon in the Google X Prize. It's a competition run by Google, and the objective is to basically land the spaceship on the moon. And I'm a volunteer in Space Eyal. They have hundreds of volunteers today, and I'm going to tell the story of how we first started to basically launch forward this initiative with an experiment of building some sort of a rocket as a side project. And do we have the video? I guess I'll just go over to my laptop over there. Okay. So Space Eyal was actually founded by a friend of ours. His name is Yariv Bash, and the objective of the competition, as I said, is to send a spaceship to the moon. And I'm going to go over a side project, which was basically building our own test rocket with the objective of testing all the electronics and guidance systems. So when we first started out, it was a very small team. It was very little funding, and they already basically put together the electronics for the spaceship. But the problem was, how were we going to test and make sure that the electronics can actually withstand the G-forces and all of the different forces that act upon the electronics on the way to the moon. So the way to do that was to build our own rocket. We first contacted Herzliya, which is an Israeli company that builds these kinds of rockets for the industry, and asked them for a price quote for a rocket that can take basically a small payload of about a kilo of electronics around 3 kilometers in the air, obviously not on the moon at that point. And Herzliya told us that they can do it for $100,000. So, and that's expensive. At that point, they still didn't raise all the millions of dollars that they did along the way. So he basically told me, and I have a very strange hobby. I built my own rockets at home, So
Can you start with your story? Was when you were, I believe, 10 years old? What happened exactly in your kitchen?
You said I need to speak for 8 minutes. I don't think that we have enough time to go back to when I was.
Okay, he just
younger,
blew up his kitchen when he was 12 or something like that. That's all.
Yeah, basically my hobby is building rockets, and I build my own launch pads and rocket engines, and brew my own propellant and so on. So Yariv, who is a friend and the founder of Space Eyal, knew that, and he gave me a phone call, and he told me that basically Raphael told them that it should cost around $100,000, and it will take around 2 weeks. And he said, Nimrod, how fast can you do it, and how cheap can you do it? And I said, well, we can launch in 2 weeks, and it will cost around 100 shekels. And we basically did it all in the backyard, in our garage, so to speak. And this is a short video that describes the process of building the rocket and testing it and so on. So the objective was to, the electronics were already built. We started by designing the rocket in 3D, in SolidWorks, from scratch. Everything from the engine and so on, we built it in our backyard.
And sorry, 100 shekels is $25, about.
Yeah, basically nothing. Basically from scratch, it's all built from available off-the-shelf material that you can get in your pharmacy. So this is a video that shows how we actually mix the explosives. This is the propellant that drives the rocket forward. It's a mixture of potassium nitrate, which is a very strong oxidizer, and sugar, glucose basically. Glucose is the fuel, and the oxidizer basically turns the sugar into a fuel. So it's all being cooked slowly over a low flame, low heat source, until it melts, and then we pour it into the rocket engine and build the engine. So we designed the rocket, we designed the engine, and then we needed to test it and make sure that it works. It's homemade, so obviously we're not completely. This is just burning parts of the propellant in the open air, and then we move forward to the static engine test. This basically means that we put the engine in the ground. The thrust is directed upwards. We're not launching anything. We're not trying to get anything to fly through the air. We just want to see that the rocket is not going to explode, and the engine withstands the pressures and the heat, and everything works fine. And we were sure that it's going to work perfectly. And then the next engine would be mounted on the actual rocket. So this is the first. This is the. See, also didn't go so well. Basically a catastrophic failure of the engine. So we moved forward and designed another rocket and made a third attempt to build an actual rocket engine. So test number 4, we made some corrections. We figured out how. And the next test was done in the Technion labs. I actually called them up and told them about what we were doing. And the first thing that came out of their mouth was, "You're crazy, don't do it. Because you're not supposed to build rocket engines in your backyard and mix explosives in your own home." But eventually they decided to let us use their labs and use proper equipment to make the 5th attempt and test the actual performance of the engine. So this
4, 3, 2, 1.
So we had 3 failures and 2 successful tests, so we decided to move forward and take the chance and try to mount the engine on an actual rocket. We built the engine, and this is the launch day. So as you can see, the rocket itself is basically just a pipe with a 3D printed nose cone and some fins on it. And very basic, very simple. It took us just a couple of days to build it. Everything was off the shelf, nothing special. And this is the actual launch date. We mounted the electronics inside the rocket. We had our parachute followed inside of it, and we were ready for launch and prayed for the best. For those of you who don't speak English, the girl there basically yelled, "There's no way it just worked." So everybody counted on my abilities to build a rocket that doesn't explode. We had 3 failures and 2 successful, tests. So it wasn't really we weren't really confident that it was going to work, but it did. And this is what it looks like from a distance. So the rocket reached the peak altitude at around 3 kilometers. Everything worked as expected. We were very surprised. The guidance system and the electronics survived the trip. The parachute deployed, and we even managed to find it and retrieve it. We got some media attention as well. And that was basically the project. That was over a year ago. Space Eyal is now, I think they raised quite a few millions, around $12 million. They're way on their way of getting to the goal. They're launching within about 2 years, I think is the time frame. Have hundreds of volunteers all over the country. A lot of the companies in Israel are supporting them. And if you want to learn more about them, there's a website, spaceeyal.com, and they're always looking for more volunteers and contributors and so on. So I recommend you go to their website and see what they're all about. Very cool team and very important group of entrepreneurs. And the objective is basically to be the 3rd country to put the Israeli flag to put a flag on the moon. And the 3rd flag on the moon can be the Israeli flag if they manage to do it. So we wish them the best, and check out their website.
Thank you, Nimrod. You are a kind of rocket maker, I would say.
Yes, so yeah. That's a side hobby. Everything and anything. That's an old hobby of mine.
Okay, thank you.